Is going to be very different, a different type of our topics. We're going to talk about combustion reactions. And combustion reactions are typically of hydrocarbons, and they burn.
Do the slide?
Oh.
I guess so.
Yeah, there it is. So typically hydrocarbons are the ones that react with oxygen, but also sometimes we can have reactions without the presence of oxygen. And so that's what the main topic of my presentation is going to be. So here's an example that we've probably all heard of octane burning in the presence of oxygen. And does anyone know why this is such an important combustion reaction?
Because it happens
go on.
in our bodies, right?
I think this is what powers our cars, so this is how we got here.
Oh.
So this is very important to being mobile in our society. Okay, so carbon dioxide can generally not support a combustion reaction, and that makes sense because it's a product, and so it can't overpower it because it's not as reactive as the carbon dioxide. However, it is useful because it can sometimes smother hydrocarbon reactions, and so as we're going to see here, we're using carbon dioxide to put out a hydrocarbon fire because it stifles it and it can no longer react with it. But there's an interesting caveat to this. Sometimes reactions can proceed in the presence of carbon dioxide, and so they've had to use other ones, and let me just look at my notes here. One of them is called bromochloro difluoromethane, which goes to our chapter 23 on naming, and the formula for that is CF2ClBr.
It's also used as a refrigerant.
I didn't know that. And it's used as a refrigerant. And so that's why they had to switch over to some other ones, because reactions can occur in the presence of carbon dioxide. And these are metals, so when metals come into contact, such as magnesium, which we're going to see, they can create a displacement reaction, which pushes the carbon off of the O2, and then proceeds as this general reaction to oxidize into magnesium oxide. And so that makes it a little trickier to deal with, as we just talked about before, because then you can't use CO2, because that will still just fuel flames and burn, and so in houses for fire departments that can be an issue. And it's a little more versatile of a reaction than a hydrocarbon reaction. Okay, so here's the reaction. Okay, so here we have it as a gas, then we have dry ice, which is carbon dioxide solid, but it's the blind and gas continuously, as you can see, this vapor going off as it just goes away. So that's why it says gas in the note here. Then it proceeds to magnesium oxide and then has solid carbon left over after the reaction proceeds. And then now we're going to connect back to our coursework again with our redox reaction. We'll see that magnesium starts in its ground state of 0, and then it moves over and loses its 2 electrons to combine with oxygen. The carbon in CO2 has the 2 double bonds on each side, so it has an oxidation state of 4+. And then moves to its solid state of 0. And then the oxygen doesn't change, which makes sense from what we know. That's one reason we're able to see what redox reactions are, because the oxygen does not change because it's very electronegative. Okay, and so now I'm going to do a little bit of experimentation. A little bit paranoid. Yeah, I'm like the only one who always wears the glasses and the lab coat, so I'm always like, okay. I don't want to end up like blind, you know. Okay, anyways. So here's a hydrocarbon. Let's try it again. Yes, there we go. So here's a hydrocarbon, and it's using the oxygen to create that combustion reaction. And if we move it into our carbon dioxide, it goes out immediately because it can't work with it. Now if we take our So this is going to burn in the presence of just oxygen, and then we'll do carbon dioxide. Oh. There we go, there it is. Okay, so there it's burning in the presence of...
We're not supposed to stare directly at it, right?
Okay, and there it is, aha, yes. See how it's, the other magnesium's lighting on fire. And so it's converting the carbon dioxide into magnesium oxide. So that's the,
I didn't know there was much magnesium in houses, though.
I think this is an example metal, but I think other metals can light on fire as well. But some I think are more reactive and we want to like blow everyone.
Yeah, once it gets hot enough.
Yeah, it can keep going. I mean, this is pretty quick the way this takes place. Is left over.
So can you explain one more time what happened exactly here?
Okay, so we took the magnesium
Mhm.
and started burning. Initially, it was using the oxygen in the air because we have something like 22% oxygen. But then I stuck it inside this little cave I made in here.
Mhm.
I'll show you. Cave here, where I had other pieces of magnesium in there too. And so I put that piece of magnesium in, and then the other one's caught on fire, and then I covered it up. So it's only carbon dioxide subliming. And so what it does is it does a displacement reaction. So there's the carbon on the two oxygens, and it moves those off, and just takes the oxygen and creates magnesium oxide when it has no oxygen to burn with. So that's what makes it a little unique type of combustion reaction as compared to a hydrocarbon that we're used to.